Greetings, mathematicians. Today we are solving an application problem with a quadratic function. We're told a model rocket is shot up into the air with an initial velocity of 288 feet per second. The function given by h of t equals negative 16t squared plus 288t relates the rocket's height h in feet to the time t after launch in seconds. So this equation has no x, no y. The input value, like x, is here t, and the output value is h of t. So if you were to write this as an equation with y, it would be y equals negative 16x squared plus 288x. But we are going to be using the variables h and t in this problem because that's what we see in the problem here. So for A, it's just evaluating input values. So h of 0, h of 5, h of 10, h of 15. So those are relatively nice. H of 0 would be the value when t is 0, so negative 16 times 0 squared plus 288 times 0. So h of 0 is going to be 0. Because 0 squared is 0 times negative 16, 0, plus 288 times 0 is 0, and 0 plus 0 is 0. So this means at 0 seconds, the height of the rocket is 0 feet, which makes sense if it's being launched from the ground. So h of 5 would be negative 16 in parentheses 5 squared plus 288 times 5. So that can be done with a calculator. When you calculate the value there, you will get an output value of 1040, which means at 5 seconds the height of the rocket is 1040 feet into the air. Next is h of 10, and that's going to be negative 16 parentheses 10 squared plus 288 times 10. When you put that into the calculator, you will get a value of 1,280, which means at 10 seconds, the height of the rocket is 1,280 feet into the air. And then our last value to evaluate h of 15, that's going to be negative 16 times 15 in parentheses squared plus 288 times 15. So h of 15, when you do that math, is 720. So that means at 15 seconds, the rocket is 720 feet into the air. Part B is asking us to find the t-intercepts, just like x-intercepts. We would let y equal 0. So that's where this equation comes in handy. You're basically setting this side equal to 0. So I'll write that over here. 0 equals, and then we write our equation, negative 16t squared plus 288t. Since it's already set equal to 0, the one thing we need to do is factor out our GCF. They both have the variable t, so t is a variable GCF. 16 is a factor of 288, so 16 will be factored out, and since our leading term is negative, we're going to factor out negative 16t. So 0 equals negative 16t times t, because negative 16t times t gives us negative 16t squared, and then negative 16t times a minus 18, so minus 18, because when you multiply negative 18 times negative 16t, you get positive 288t. Now that our factors have been set equal to 0 and they cannot factor further, we set them equal to 0. Negative 16t equals 0 and t minus 18 equals 0. From our first factor, our solution for t is 0. That is a solution. From our second factor, t equals 18. Since 18 minus 18 equals 0, and over here, negative 16 times 0 is equal to 0. So these two are our solutions when y is 0, which means our intercepts, our t-intercepts, would be 0, 0, and 18, 0. The last part, C, is asking us to find what time is the rocket, how many seconds go by before it's at a height of 1152. So we're given a y value to substitute of 1152. So instead of setting it equal to 0, we're going to set it equal to 1152. equals negative 16t squared plus 288t. We are going to solve this equation for 0, and a quick way of doing that is subtracting 1152 from both sides. So 0 equals negative 16t squared plus 288t minus 1152. There is going to be a GCF. 16 is actually a factor of 288 and of 1152. So what we're going to look at right now is set this equation 0 equal to negative 16 is going to be our GCF. So negative 16 times t squared. And then we have negative 16 times a negative 18, and negative 18t gives us our positive 288t, and the last one is going to be negative 16 times a positive 72. That gives us our negative 1152. So this trinomial can be factored further. And because the a value is 1, we can just write the factors for it. So 0 equals negative 16 times t. The two numbers, by the way, that multiply to give you positive 72, but when you add them give you negative 18, are going to be negative 12 and negative 6. So t minus 6 and t minus 12. Negative 6 times negative 12 does give us a positive 72, and negative 6 times negative 12 does give us a negative 18. So now we can write our solutions. T equals positive 6 from this factor of t minus 6, and here t equals positive 12. From our first factor, it would be a contradiction, since negative 16 equals 0 is a contradiction. So now, let's interpret the problem. At 6 seconds, the height of the rocket is 1152 feet. And it's also at that same height at 12 seconds. And here is actually a graph that verifies most all of our answers here. So here's the 6, 1152, and here's the 12, 1152. Here's our t-intercepts, in this case, 0, 0, and 18, 0. That's how you solve example number 7.